Everything is being influenced by code written by developers.
At some point, you're going to wake up and say, what the hell am I doing?
It's hard to believe. It's the largest group I've ever been in front of, I think.
We develop the future.
Hello everyone and welcome to another episode of the WeAreDevelopers live sessions. My name is Benedict and I'm so glad that you all made it today. Today will be all about JavaScript, the programming language the whole internet and therefore all of humanity depends on. But before we come to that, I have some great news for all of you. Our World Congress is back as an in-person event in Berlin starting June 14th. So don't forget to go after the session to worldcongress.dev to save your tickets. Also, during the talks, feel free to interact with the chat to your right. Submit some questions for the speakers as we will have a short Q&A afterwards. But keep in mind that we have a code of conduct. Here's a short video about it. So, right back to JavaScript. The first speaker of today is principal developer and product owner at Dynatrace. He has been working as a professional software developer for more than 20 years now, and he loves writing code, tinkering with electronics, and building Lego with his kids. Please welcome with me, Wolfgang. Hello, Wolfgang. How are you doing?
Hi, friends. Yeah, as we said, my name is Wolfgang. You can find me on Twitter or GitHub with the handle here in the lower right corner. And during the day I work at Dynatrace. We at Dynatrace, we are in the observability and distributed tracing space for a very long time now. And naturally, we got interested in a project like OpenTelemetry, and we support OpenTelemetry as a data source to Dynatrace. But we also have been contributing to the OpenTelemetry open source project from the very beginning and are among the most active contributors to the project, in fact. But that being said, this should not be a talk about Dynatrace or let alone some pitch or demo session. This is really about OpenTelemetry today, as it should be, as an open source project, as a vendor neutral project. And as a tool that's open and for use to everyone. But what is OpenTelemetry actually? Well, OpenTelemetry is about observability. It's about getting telemetry data out of your application. Typically, when we talk about observability, we talk about the three pillars of observability. These three pillars are traces, metrics, and logs. Metrics and logs, most people have a concept of how those work, but maybe not so much about traces. And this is the first and almost want to say most important pillar for OpenTelemetry. That's where everything started. And we will talk only about traces today. Each of these topics could have its own session. We can go into details, but let's get a basic overview of how distributed tracing works in this session. As I already said, OpenTelemetry is an open standard. It's an open source project. You can find the project here on GitHub with the URL here. And it's started out as a specification. So the specification says, gives a guideline on how to implement this framework or this project. And then we have many language-specific implementations which follow the specification and provide the actual product to the implementers. And one of these implementations is, for example, OpenTelemetry JS, which we will talk about today. As the name suggests, OpenTelemetry JS is about JavaScript, and it's implemented in TypeScript, which means it can be used in the browser and it can be used in Node.js. Today, we'll focus on the Node.js aspect of OpenTelemetry JS. I could now go on and on with such bullet points about OpenTelemetry, explain different concepts and try to motivate it, but I think the biggest motivation actually is to ask the why question. Why would I need OpenTelemetry? Why would I need distributed tracing at all? And the picture that I always use to illustrate the why is this. So what do we have here? This is a microservice application landscape. More specifically, it's the microservice application landscape of Uber, the famous ride-sharing company. More specifically, it's a snapshot of a given point in time how the Uber application landscape looked like. Because all these green dots here, those are microservices. And as you can imagine, this is ever changing and ever evolving. So it's not a static thing. And if you look at the gray connections between these green dots, well, these are basically communication paths between all these microservices. And if you look at the dark arrows here, this is actually a perfect example of a distributed trace, or also a business transaction within this Uber microservice landscape. Let's say we have a mobile application here where everything starts. User orders the ride with the mobile application, and then the workflow is kicked off. It goes through various services until finally, hopefully at the end of it, some Uber driver is notified, comes around the corner with his dark blue Toyota Prius or something you've been waiting for, then you get on the ride and everything works. Well, if everything works, that's the big caveat here, right? Because what happens if things don't work anymore in such a complex and distributed system? Let's just imagine the network connection breaks. Then we suddenly have a cascading error. The next thing breaks, and the next thing, and the next thing. And at the very end, we have one really frustrated user. And now the goal is, if such a problem or such a scenario occurs, how to track down the problem, to do an examination afterwards, to do some post-mortem and find out what went wrong. And this is where distributed tracing is probably helpful. But let's approach this maybe from a historically or evolutionary perspective. What can we do to deal with this kind of problem? One solution, maybe not the best one, is sit it out probably, because 99% of the time everything works, and then there's this one tiny error that occurs sometimes in production with no chance to figure it out with a unit test or integration tests, so you just live with it. Is it a good solution? Probably not, but it is a solution. Can we do better? Well, one often taken approach is blame it on the hardware, right? Probably it's a resource problem with your memory or with your CPU. So we bring in more hardware, we rent another cloud server, we buy a rack for our on-premise data center, and hope the error goes away. Fundamentally, this is not so different from what we did before, just sitting it out. Only this time we spend some money, so we can feel good about ourselves, but it's not really solving the problem in a scientific or in an organized way. So let's see, can we do better? Well, one approach is investigate manually, maybe. Have someone sitting in your control room, monitoring all the services, maybe attaching a debugging system to your application, and try to find out where an error occurs or where the problem occurs in production. Yeah, this might be a thrill for the first time. Feels like solving a puzzle. So feels like solving a murder mystery. Maybe it's interesting the second time, but yeah, the third time it probably starts getting a bit tedious and it starts getting old really, really soon. So no, we need to find something better. For years and years, the scientific approach, let's say, or the more organized approach would be to look into logs and metrics. We all have seen probably these server log files, thousands and thousands of lines of code, where you grab for specific patterns, look for specific patterns that might indicate an error. It's also more organized than before, but still manual and tedious work. So what about metrics then? Yeah, we all have seen these dashboards where the metrics of our applications are visualized. So let's say we have a nice metric there for the response time of our application. Then we notice that our application becomes slower, and we see the same information in the metric. So it looks nicer, we have a nice graph for it, but did we really gain information? Yeah, probably not, right? We have to find the root cause. And then that's where OpenTelemetry can come into place. It's connecting all this information. And if we go back to the image that we saw initially, this is the solution to this problem, right? It's figuring out the instance when the error probably occurred. So we want to really find out that's the distributed trace. So the transaction starts at a given point in time, at a given service. Other services are involved, and we want to be able to have, for example, post-mortem analysis. We want to have exactly this picture and know which services were involved and probably where the error occurred. And OpenTelemetry will help us with that. But enough with the slides, enough with the preamble. Let's look at some code now, and that's how we can actually make use of it. So to get started, I prepared this very, very basic Node.js script. It just pretends to do something important here. In fact, it just prints to the console. So we have this main application here that prints when it starts and when it ends. It accepts as an argument a number of jobs, and given this number of jobs argument, it calls a helper function called toWork, and this toWork function just burns through the CPU to simulate that some time has passed, and we also log something to the console, and we're done. So nothing really useful, but it illustrates a concept, right? It illustrates some job dispatching service probably. So we have a main service, and this distributes work to help our routines here. So let's run this quickly to see if it behaves like we expected. But, okay. You see, as expected, we have the main function starts, then we have 10 jobs scheduled, and then the schedule executed, and then the main function ends. Let's say we want to add tracing, we want to add OpenTelemetry to this application. How would we do that? Well, let's improve on the sample we just had. First, we need to bring in OpenTelemetry as an MDM package. I already prepared that. If you look at the package.json here, there are several packages available for OpenTelemetry. You can just bring into your project. What we do here is we start with the API package. It will be important later, keep that in mind. That's our entry point here. So we say, okay, we want to have the OpenTelemetry API in our application. Then we use this API to get a tracer. Now, what is a tracer? Well, let's say the tracer here is again, it's our entry point into the world of OpenTelemetry. We use this tracer to add information, to add instrumentation throughout the rest of our application now. A tracer can have a name, we call it server, same as our JavaScript file here. Reason is you can have multiple of these tracers, and by identifying with a name, you always know which tracer was used to trace a specific aspect or part of your application. Okay, so we have this tracer. And remember, we have the main function we called there, the argument of 10, where everything starts. And inside this main function, we use the tracer to start a span. Now, what is a span? Well, think of a span as a logical operation inside your trace. So I always use the analogy of exception stack trace. Most of you or everyone probably is familiar with an exception stack trace, right? So if an exception occurs, you have all these, you have the stack trace, and each line in the stack trace represents one function that was participating in this call that led to the exception. Distributed traces are the same or very similar. It's only it's not tied to one process, but it's multiple processes or services or whatever threads connected to each other. And the smallest unit inside such a trace is a span. So to trace our main function here, we create a span and call it same as the function, main, and the object, the span object we receive, call this the main span. At the end of the function, we end the span again. So the span has an end method to signify, to show that the span is over now. Implicitly, with calling start and end, every span gets a duration because we take the timing when it starts and when it ends, and we know how long an operation took. Additionally to the name, we can also give other data to such a span that we can recognize it later. This data is called attributes. It's basically just key value pairs. So you can call this an attribute function on a span, and for example, for this span, we want to capture this argument here, this number of jobs. We are interested in that later, so we set it on the span. Then the rest of the main function is as it was before. Only when we call the doWork function, we pass this main span that we created as an additional argument into the doWork. We will see now why. In the doWork, we refer to it as the parent span, because what we want to do is we want to establish a parent-child relationship with the tracing that we added to our application. We say this is the main span, the parent, and this launches a couple of work jobs. So these are the logical children. For that, we have to do some OpenTelemetry JS magic here. Basically, we need this parent span and convert it into a so-called context. This context is then used as an argument to the start span function, and this establishes the parent-child relationship. Then we can set attributes on the span, on the child span. In that case, we want to capture the worker number. We also gave it, before we gave it a name, we call this same as the function. We also called it doWork. And then we end the span, and the rest of the application is the same as before. You already see we had to add quite some lines of code just to bring instrumentation, just to bring observability to our very simple sample, because we did everything manually. But we'll get to that later. For now, let's keep going. Let's execute the application again. Now with the saved this before. Now with the added tracing, and nothing happens. Did we make a mistake? No, that's actually intentional. Remember when I said we bring in the API? That's one of the fundamentals of OpenTelemetry, one of the fundamental concepts. We have a strict distinction of the concerns API and SDK. As long as I only use the API part of OpenTelemetry, I add little to no overheads to my application. It's basically all these calls here that are executed are glorified no-op operations. It's really, I made my application ready for tracing, but it doesn't do anything. It doesn't extract any data. What I have to do for that is I have to bring in an SDK. So that's the other fundamental part of OpenTelemetry. But before we do that, let's pause here for a second and see what we learned so far. So, lights here. There we go. Okay. First first scenario, so we add simple tracing, right? What did we learn? So we have the OpenTelemetry npm packages that we can add to a Node.js application. We know what a tracer is and how to create a tracer. So it's our entry point into the world of OpenTelemetry. It helps us to create, or it's used to create the spans, right? That's what we saw. A span, as we said, is a logical operation. It can represent, for example, the whole lifetime of a function, but it can also be a more abstract or logical operation. Let's say we have an outgoing network call. This can also be a span. So in the middle of your function, you do an HTTP call, and you just want to trace this little this little part of your function as a span. It's also legit. It's just a logical operation within a trace. Span can have a name. It automatically gets a duration with the start and end semantics. We have a parent-child relationships, and we can put attributes on the span. And what we heard at the end of the demo is that we have this separation into API and SDK. So as long as we only use the API, nothing really happens. And what is the idea behind that? Well, if you, for example, develop a library or a module for something, let's say some networking library or some database access library, you can add tracing and OpenTelemetry from the very beginning by just using the API. If someone is using then your package, tracing is already in there, but as long as no one turns it on, it doesn't add any overhead. But as soon as someone uses OpenTelemetry and uses your package that has tracing or OpenTelemetry already built in, it really lights up, it really shines. Yeah, it takes place in this distributed trace and helps users to diagnose better what's going on in your module, what's going on in your library. So that's one of the biggest strengths of this separation of API and SDK. Now let's see how we can get an SDK into our sample application. For that, I require a couple of more data types. See, we had the API as before, but now we also take some data types from the SDK tracing package. It starts with a so-called tracer provider. The tracer provider is basically your, it's the entry point into the SDK. As soon as someone later requests a tracer, the tracer provider will take care of getting a tracer that actually does something that actually extracts data. So such a provider, what else do we do? We add a span processor. Now, what's a span processor? Well, a span processor is, you can have basically an implementation of an interface. The simple span processor is an implementation of that. And what it does, it gets invoked every time a span is created, a span is ended. The span processor then can decide what to do with the span that was created. In our case, with the simple span processor, we immediately hand it down to an exporter. What we're using here is a console span exporter. As the name suggests, it exports spans to the console, just prints it out. So it's for debugging or just for informational purposes. So no real data export per se, but it's printed to the command line. So that's the idea behind it. So it's more or less a supportability or debuggability concept, this span exporter. But it's good for illustrating concepts. Last but not least, one line that we added here to our sample to bring in the SDK is to register the provider that we created up there. If I comment this code and run the third iteration of our sample again, nothing happens, same as before. But as soon as I register the provider, the SDK becomes active, and we see a lot more output than before. So that's now really the power of OpenTelemetry. By just making the SDK active, suddenly things behave differently. Things spans start to show up. As I said, in that case, we use the console span exporter. So every span that's created in our sample application here, the main span and the worker spans, will show up on the console. So let's look at those spans. Our application, as usual, starts with the main starts console log output. Then the first job is started. And then the span gets printed to the console by our exporter. So let's look at this span. Do we recognize some of the attributes in here? Well, we see the name, right? The span who worked. It's the span that we created here. Then we see that we have an attribute collection on it with the attribute that we set here, the worker number. Now that's data set by us, but what else is in there? Well, we see we have a trace ID, right? We also have another ID and we have a parent ID. So if we look at this trace ID that starts with A5F99 and so on, this one is the same on all spans exported here. So this means they all belong to the same trace, they belong together. They have been created by the same tracer object. If we had instantiated another tracer, a second tracer, the spans would get a different tracer ID. But here all the spans belong together, right? They have been created by the same tracer. They have a unique, every trace has a unique ID. Additionally, every span has its own unique ID as well. So this first job has a unique ID, second job has a unique ID, so they are identified uniquely by that. What else do we have? Well, we have this parent ID here. What's that? So let's look at this parent ID. It's 27B60 and so on and so forth. If we look for this, this is the span ID of our main span. So now we know how this parent-child relationship is actually modeled in data, right? It's actually modeled in our span data structure. Every span has a parent ID, and if this parent ID matches the ID of another span, well, we have a parent-child relationship. And as we almost can expect now, the main span we have here has no parent ID, or has a parent ID of undefined here in JavaScript. So this is where everything starts. We also speak of this as the root span. So the trace starts here, and then we have a couple of child spans. Yeah, so that's basically how this parent-child relationship of the spans is established. Now, exporting data to the console is nice and fine, but we want to do better. We want to see more. So we want to get the spans out to some tracing backend where we can visualize the data, where we can work with it, where we can see it. And one example for such a tracing backend is, for example, Jaeger. Jaeger was developed at Uber. Remember the picture that I was showing you before? They have been in distributed tracing for a long time, and they developed their own tool for that. It's also open source, and it's used very often because it's really simple and easy to use. It's available for many operating systems. You just download it, run it as a single executable. It sets everything up for testing. So it's really easy and nice to use. And it has a nice front-end UI where you can visualize your traces. But in order for traces to show up there, we have to export to Jaeger first. So let's go back to our sample. And instead of having a console exporter, we have a so-called Jaeger exporter now. For that, we also require an OpenTelemetry NPM package that's adequately named exporter Jaeger. This one has the Jaeger exporter in it. And we just register it here, and we wrap it in a span processor, have the Jaeger exporter, and we run the very same application now that we had before, that printed the spans to the command line. Only this time we only see the expected log output. If we switch back to Jaeger here and maybe refresh the UI, we see the WeAreDevs demo. That's how we named the service here for Jaeger showing up. And if I hit find traces, voila, suddenly I see the spans that I created in my application showing up in the UI here. We recognize a couple of things, I guess, here in the UI. So we see we have our main span here, and then we have 10 instances of the WeWork span that we created. We also see here the timeline, like the duration of the main span. It lives as long as all its child spans. Then we have a nice waterfall diagram of where the child spans are started and ended. Looking, for example, into the data of one of these spans more in detail, we see that Jaeger uses the terminology of tags here, but these are basically the attributes that are set on such a span. We might recognize, for example, the worker number. That's attributes that we set, but then there are a lot of other attributes which are automatically set by OpenTelemetry when we export it. For example, OpenTelemetry says which language we're using, or Node.js, yeah. Then as the SDK is by design pluggable, it also gives the names. It could be some custom SDK here that someone else implements, so then I would have another name. But in this case, it's OpenTelemetry, and they even see the version. Going to our main function, we see, for example, the worker number attribute that I set. So, yeah, admittedly, we had to write a little bit of code to add instrumentation to our sample app here, but the result is quite powerful, right? We automatically get the data visualized here in Jaeger, and if we had some error, well, if we suddenly, for example, one of these spans took way longer than expected, we can immediately diagnose the problem by having the visualization. All right, it's another good time to take a quick step on the break quickly and see what we learned so far. So we're still in this very simple first scenario where we have an isolated application, so just one application, to which we added OpenTelemetry. But we learned that OpenTelemetry is really extensible. So we have this separation into API and SDK. And if we bring in an SDK, we can add different kinds of exporters to the SDK. So we learned about the console span exporter that we use for debugging and testing. And we also learned about the Jaeger exporter, where we can export our spans to the Jaeger tracing backends. And of course, there are other backends. For example, Dynatrace would be one of the backends to which you can export your spans. Or there is Zipkin and Datadog and Elastic, and yeah, a lot of offerings there in the observability space to which you can export your spans. But now, as I said, we were only dealing with a single application all the time. So this is not really distributed tracing, right? Because we have one process on one machine. What's distributed about it? Well, yeah, admittedly nothing. So let's take the example a little bit further and look at the client-server application. So if you look at this graph here, this is the most simplified version of the picture I showed you before, right? Only in that case, we just have two services. They are connected by the network, and this is the client, this is the server, and they talk to each other. Let's see how we can add distributed tracing, or how we can open telemetry to the simple client-server scenario. Again, let's go back to the code for that. So since we have a client and server now, we bring up two console windows. Okay, client server. Again, I used a really very basic example. So I have a Node.js server here. This is the port number 4589 that I passed to this server function. Server function instantiates a very simple HTTP server, and here in the handle request function, we get the console output as soon as a request comes in. It says handling request, and then it sends a response to the client, and the response says, hello, we are developers. Look at the client part of this application. It's basically just a single request to the service running on localhost with the port number we already saw. And when it receives the response from the server, it prints it to the console. So we expect that the client is saying, hello, we are developers. Let's verify if we implemented this correctly. We see, okay, the server is listening on named port. We launch the client. Server says handling request, and the client says, hello, we are developers. Okay, everything works as expected. Yet no OpenTelemetry is in there yet. We have to add this as the next step. look into the first iteration of this sample. Let's start with the server maybe. So what we see here in the first line of our sample function, what the code that we had to add is we require a file called tracer. This is where we moved all the initialization logic of OpenTelemetry that we had before. So we see this is where we bring in the API, and this is where we bring in the SDK and the Jaeger exporter, and where we set everything up and register the span processor, and then we return the API object to the caller. This is a very typical pattern you will find in OpenTelemetry Node.js applications, that you have this shared or this file called tracer or setup tracing or setup OpenTelemetry or whatever it's called, where you try to put in all the code that's really necessary, all the boilerplate code for initializing OpenTelemetry, and then it's used in the rest of the application. The rest of the application is just making use of it where necessary. In this case, even the server and the client, they are sharing this tracer module here because they have the same kind of initialization. So let's have a look what's going on here. The start server code that we had, that remains untouched, that remains the same. We only added some instrumentation to the handler request function here. So the first console log is still the same. And then as before, we use the API to retrieve an instance of the tracer. So in that case, we call the tracer server. And with this tracer, we start a span that's called, again, the same as the function. It's called handle request. So we are handling the request, and when the request is finished, we end the span and we are done. So we expect the server to produce one single span. How does it look like on the client? As I said before, we are sharing this tracer initialization file, so we also require the API like this. Then we create the tracer called client here. We start a span that's again called the same as the function. It's called make request, and then we set a couple of attributes on the span that we are interested in. Because what do we want to do here? We want to describe this HTTP GET invocation, right? We want to describe the request we are making. So we say one of the attributes is the host to which we're making the request. It's the localhost. Then the port is interesting. It's all data that we want to have later available in Jaeger or in our tracing backend. So we put this on the span here. We set the path and we set the HTTP method. And we all do this manually, right? And if you see this comment here, I deliberately introduced an error here to indicate the pitfall here or the problem here. If we have to do this manually, we will probably make mistakes, right? I switched the last two digits here. This is not actually the port I'm listening on. So when I'm describing the application now with distributed tracing, now I have false data in it because I have to do this manually. And we can do better, but we will see about this later. But now let's only see if we can actually run this application, and then we take a look at the data. So start the server again, start the client again. No output because we are, if you remember the tracer file here, initialization, we are already exporting to Jaeger again. So let's see. Jaeger again. The Jaeger UI, and we are expecting new services to show up here. So, and voila, we have a service for our client. So if we find the traces for this one, we see, okay, we have created one span for our HTTP client. We have the metadata on it that we set. So we see we have the port where I made the error with the swap digits. We have the service name that we set. We have the HTTP method get, and we have the path and so on and so forth. And if we look at the HTTP server, find the traces for it, we also see the span that we created manually. So we named it handle request, and in fact we didn't put any additional attributes on that. It's just wrapping the with the incoming request. But actually, we didn't really improve something compared to the initial example, right? So we still have these services pretty much separated, like we did with the initial WeAreDevs demo. Actually, what I would expect here is that this client, HTTP client span, gets connected to the server span, because that's the whole point of distributed tracing. Right now, I'm tracing all my applications individually, but I want to bring them together. I want to have a, as the name suggests, a distributed trace. So let's look into the code how we can do that. Again, let's evolve the sample we already have here. Starting with the, let's start with the client now. And the beginning of the code is untouched, it's the same as before, but this is the code I have to bring in, this is the code I have to change to get the spans actually connected. And the concept I'm using here is called context propagation. For this, I'm using a new API of the OpenTelemetry API that I required here. That's called inject. And I inject into just now empty headers object my custom, or in that case, I call it my fancy HTTP or my fancy header. I add an HTTP header basically, and I serialize the context of the active span and put it on the header. So every span has a context, and that's the serializable part. So if you remember all the ID information we had before, like the trace ID, the span ID, and the parent span ID, that's basically the context. That's the serializable part of the span, and I put this one on the header. And then with this call, I have it on the header, and I take this headers object and send it with my HTTP GET request to the server. And if you look at the server application now, most of the code is unchanged, except as well for the propagation API call. Only here we call extract instead of inject, because we want to do the opposite. Yeah, we want to look at the HTTP headers that are coming in, and I want to pick off this one header I'm interested in, my fancy header, and OpenTelemetry takes care to deserialize this again and make a span context out of it, and then I can use this span context as the parent for my handle request span that we saw before. So I put it in here. In this way, Jaeger is able, or the tracing backend is able to connect the spans to know that they belong together. So let's see if this actually works. Launching the server here again. Third iteration of the server. Hold on. Here. So this is the right one to start. Okay, start the server. And okay, it's listening on the port now. And as soon as I start the client here, what we immediately see is I also added this console log line dumping out the request headers, and I see my fancy header showing up in the HTTP headers coming in. And the value of this header looks suspiciously like some span context or some trace context information. So looking good. If we go back now to the legal backend, we see another service showing up, this time the .2 or 02, so the next iteration of our project here. And I already have two spans in it, exactly what I wanted. So you see, I have the make request span, and its child span is the handle request on the server. So by propagating this context information over the network and then reporting it to the tracing backend was able to connect traces and visualize them really in the parent-child relationship as expected. Pretty nice. However, do you remember the amount of code we had to write to get this working? That's that's kind of tedious, and this is really not something you want to do each time when you add tracing or when you add OpenTelemetry to your application. Well, fortunately, OpenTelemetry, OpenTelemetry JS thought about that. And this is especially where dynamic languages like, in this case, JavaScript or Python really shines, because by bringing in a so-called instrumentation package, we can add instrumentation on the fly to existing packages and modules. In this case, if we look at our tracer initialization again, what did we add here? Well, we added something called an instrumentation, specifically an HTTP instrumentation. And after registering the SDK, we also register instrumentations here. In that case, we only use the HTTP instrumentation because in our sample, we're only using HTTP. But let's say we're using another communication mechanism like gRPC. Well, there's an instrumentation for that. Or that we're using some database client library, MongoDB or PostgreSQL or whatever. Well, there's an instrumentation for that. And this instrumentation just patches an existing Node.js module and make sure that OpenTelemetry is in there. And by bringing that in, we can dramatically reduce the code that we had to write before to add tracing applications. So if you look at the client, for example, again, all we are doing now is recreating our root span because we still want to have that make request span. We want to recognize that one. And then we use a new API call. This is called context.with. Basically, we wrap the HTTP operation in this context.with, and this takes care of instrumenting the outgoing data automatically. All handled by OpenTelemetry. If you remember, this was the place where before we had to manually inject this header, where we manually set the attribute, where we even made a mistake by manually setting the attribute. Nothing like that anymore. And on the server, we have the same. In the hands of request method, before we even manually create the span, we already have a current span. I said magically here, but well, of course it's not magic, it's OpenTelemetry, and OpenTelemetry has instrumented the HTTP framework and sees an incoming request and creates an HTTP span for it. And then we can we can still, if you want, create manually a span and link this to this automatically created one. Let's see how this looks in practice. Okay, starting the node server, starting the client again. And yeah, small change we see on the command line. I printed out the trace ID of the span that was automatically created by the framework to see that something's going on here already. But we can see it better if we move back to Jaeger UI. Refresh this quickly. And we have the client 3 service here. If we find the traces, well, very nice. Now we have 4 spans. So we have the make request span that we created manually with our tracer. We have the handle request spans that we created manually. And then we have these 2 spans named HTTP GET, one created on the client side, one created on the server side. And if you look into the metadata of these spans, we have a lot of data on that, and everything provided out of the box by the instrumentation. So we see, again, we have the port number, only this time it's correct, right? No chance to make a mistake here. We see the transport that was used, TCP IP, we see the IP address, we see the host name, we see the full URL. So a lot of data is put on the span automatically that helps us diagnose a certain workflow later much more easily. Yeah, and that's the full power basically of OpenTelemetry. It's writing these built-in instrumentations that really gives you deep insights into your application. And by having all this logic in a central place, like we said before, we have all this initialization logic here in this tracer.js file. It's very easy to add additional export so diagnostic mechanisms. For example, let me quickly switch into the correct application directory. Okay, so what I did, for example, here is I added diagnostic logging, because sometimes things go wrong, sometimes you make a mistake, or you want to have more information about what's going on in the application. Well, you can add diagnostic logging. So if, for example, I run the server here again, I see some additional log output. And interestingly, I see OpenTelemetry Instrumentation for HTTP says, hey, I saw that you're using HTTP and I'm applying a patch for it. What is this patch? Well, that's what I just mentioned. It's adding instrumentation on the fly. It's taking care that we get these spans out of it without us having to do anything. And the same we have on the client. We also see that the instrumentation kicks in, and then we get some even more diagnostic output from the Jaeger exporter, see how much data was sent to the backend and so on and so forth. But as I said, the whole power of having this in the central place is I can add additional additional exporters there, for example, if I like. And that's what I did. I added the so-called OTLP, which stands for OpenTelemetry Protocol exporter. I added this as a span processor, and I used this, for example, to add export the data to another backend. But let's quickly look into Jaeger again. So back at our application. So this is the last iteration of the sample. I removed all the handwritten code about creating spans manually, about creating tracers manually on the client, on the server. So it almost looks like the plain sample with what we started out initially, right? We just have a make request here, and that's what we still have. The only thing we do is we require this shared tracer file and wrap this into our context. And on a server, we have to do basically nothing besides requiring the tracer, and everything else is handled by OpenTelemetry. So no need to change the code, and no need to do any manual instrumentation, and we get the full observability. You see we have the client span, we have the server span, and we have all the data on it. And as I said, if I want, I can add other backend, other exporters here in my tracer.js file. In that case, for example, I went into and exported my data also to Dynatrace. So if I look at the distributed traces here in Dynatrace and see what happened in the last 30 minutes, and see I have I have the same trace here as I had in Jaeger before. That's great. I have the HTTP GET on the client side. I have the HTTP GET on the server side, and we recognize all the attributes that we said before. So with just adding a single line of code, I can service different tracing backends. And that's basically the full power of OpenTelemetry. And this basically concludes the demo. So going back to the slides, we went from instrumenting a single application to the client-server scenario. And learned how to connect two services talking to each other. And from there, from this scenario, this is just extrapolation, right? It's instead of two services, you have multiples of them, but the concept is the same all the time. And with that, I want to say thanks for coming to my talk and for your interest in OpenTelemetry. But before I really end, I want to have one thing. If you only take one thing away from this session, if the only thing you remember is this picture here, then I have succeeded. So you can forget about all the terms I introduced today, all the code, all the tools, etc. Just keep this picture here in mind. Yeah. Should you work on some distributed application as a microservice application in the future and encounter a problem and you don't know how to diagnose the error, remember this picture, remember distributed tracing, and remember OpenTelemetry. I'm really done. Thank you.
Hi, Wolfgang. Amazing talk. Thank you so much for it. And I also might add, I always love to see people using Visual Studio Code. It's also my editor of choice. So we have a few minutes left, and maybe we'll jump into a short Q&A, I would say. Maybe first question, would you mind telling the audience and me what like a normal day at Dynatrace looks like, if there is something like normal?
Yeah, let's maybe start with a normal day in my team, because Dynatrace, meanwhile, is a huge organization. Every team works a little bit different, but yeah, especially in my team, we start the day typically with our so we are using agile methodology, and we're using the Scrum and the daily stand-up, and that's where we usually meet over Zoom. We're doing this even more, of course, since the pandemic, and everyone is working at home. But in my case, we even did this before most of the time, because my team is distributed among multiple locations within Austria. So there are people in Vienna, people in Klagenfurt, and of course in Linz, where the headquarters of Dynatrace is. Yeah, and then so in stand-up, we organize our day. Typically discuss what's to do for the rest of the day. If we found anything, any problems, anything that we work on, and then yeah, everyone basically does their job, and then when we need to sync on data, everything happens via video conferencing and Zoom and Slack. So we work in a really distributed setting, I have to say.
All right, very interesting. Are you looking for people right now at Dynatrace?
Yeah, as everyone, we are of course hiring. So if you're interested in distributed tracing, or yeah, or generally in observability, Dynatrace is always happy to hire new talent. We are looking for people in all the locations. So go to the jobs page. I'm sure there's something for you. We cover a lot of different technologies, languages, frameworks. There's usually something for everyone. Yeah.
All right. Maybe also as a tech guy, do you remember the first PC or machine that you worked on or gamed on or whatever?
Oh yeah. I have very fond memories of the first computer my father brought home in the early 90s, I guess. So it was some 386 Intel computer running Windows 3.0, I think, with 4 megabyte of RAM, and this was really considered a high-end machine at that time, and I could run a lot of games that my friends couldn't, and yeah, I was very happy with that. And now everyone's carrying basically a supercomputer in their pocket, and we use it to watch pictures of cats. So that's how videos of cats. It's quite funny retrospectively. Yeah.
Compared to the high end of that time, it's really a supercomputer. You're right. Yes.
It is. Yeah.
Yeah. Good old times, simpler times.
Simpler times.
So, all right, Wolfgang, thank you so much for the talk. I hope you had as much fun as I did.
Definitely.
I wish you a nice day.
Thanks for having me. Have a nice day too, and yeah, I'm looking forward to hearing the next session.
Thank you. Bye.
Bye.
So, and I would say without further ado, we will jump to our second speaker of the day. He's senior front-end developer at Intype, has been working in the front-end area for 5 years now. He's interested in Rust, Rescript, but foremost TypeScript. Please welcome with me, Serhii.
Hi, everyone.
Hi, Serhii. How are you doing?
Thank you. I'm fine. And you?
I'm fine too. Thank you so much. Would you mind telling us what we are going to hear from you today?
Yes. Today I wanted to cover most popular questions about TypeScript, which I had encountered on Stack Overflow, because I spent maybe too much time on Stack Overflow answering such type of questions, and I try to gather all most interested topics in one place.
So in the future, you can just send the video link and
yes.
Perfect. Very smart. So then I would say, without further ado, Serhii, the stage is yours.
Okay. Thank you very much. Also, before we start, I would like to thank all of you for support of Ukraine, because I'm from Ukraine and I'm in Ukraine now. please stand with us, stand with Ukraine, and please help us save our city, Mariupol. Okay, let's start. First of all, I want to start from function argument inference. For example, let's start with very simple function. As you might have noticed, I have add generic object. And what I want to do, I want to infer my argument, but I want to infer literal number, not just, as you see, prop number, but prop 42. In order to do that, I just need to add another one, generic. It's called prop. And this line means that TypeScript, please infer our property value and infer our whole object. With help of these two generics, I'm able to infer prop 42. So here we have prop 42, and here we have prop number. I hope it's clear. But with help of this very simple technique, we can infer very complicated objects. For example, here I have created, like it's very popular type it's called JSON. You can see that it's just union of null, string, number, boolean, etc. So it's very straightforward type. What I want to do, I want to infer the whole object with all keys and literal values. So here we have one generic for our keys, like prop or something like that, and another one generic for all our values, which we may encounter in our object. And this, like most common type for our argument, it includes our all inferred properties and values. So what we have here, as you might have noticed, we have inferred prop 42 and greet hello, but we were not able to infer literal value of C property. As you see here, we have just string. It is not literal value, but we still want here to be nested property. In order to do that, we can use recursion or recursive type. So here we can declare our object. So here we are inferring object, but here we are using recursion. What does it give us? You see nested property. So object infers itself. It's a very interesting trick. Okay, so now we all know how to infer these values. We can switch to our next topic. Next topic is validation inference. So what does it mean? It means that, for example, we have some function and we want to pass to this function any argument except an array. Believe me, it's very useful. Maybe not in this particular function, but in general, usually people want to validate something. I will show you like more complicated techniques in our next section, but please, it is crucial to understand what's going on here. What does it mean? This function infers our argument, and TypeScript allows us to use conditional type in a place of argument. For example, what does it mean? TypeScript infer our argument, then TypeScript compiler checks whether this argument is a subtype of an array. If it is a subtype, it is it's simple like ternary operator. Just you can treat it. If it is an array, it will return never. Otherwise, it will return our past argument. So here, TypeScript allows us to use 10, allows us to use hello, but it doesn't allow us to use array. As you might have noticed, array is replaced with never. It is also, it's very interesting and very important. If you want to forbid something, you need just replace it with never, because you're unable to to create a value which will be inferred as never. So it is possible with type assertion of or with throwing an error, but it is not the case in this place. Okay, so now we know how to infer our argument, and we know how to forbid something. It means that we can go to our next section. What do we want? What do we want to do here? Let's remove this type. I know it's complicated to understand what's going on here, so I will remove it and write again. So what do we want to do here? We have a function foo. Here I have used the same technique as we have to use here. So function will infer the whole object. We want to infer our keys, our values, and our whole object. And we want to use our previous technique. It means that we won't allow any argument, but we want to forbid name property. For example, TypeScript should highlight this name property and tell us that, hey, you are not allowed to use name property. Believe me, it also very useful, especially if you want to forbid some properties with underscore. How do we want to do it? In order to do that, we need to iterate through all keys of our object. This syntax is you can find in TypeScript documentation mapped types. It just iterates through all keys, like simple for in loop in JavaScript. Prop in k of object. So I will try. I will start with very simple case, just to make sure that you understand what's going on here. For example, we have an object here. I will copy and paste it. Make it clear. And name. Okay, for now we don't forbid anything. What do we do here? We just iterate through all our keys, and we just replace each value with current property. In order to leave this object as is, we can just do object prop, and this object, we just leave it as is, no changes. How do we can to forbid something? We need to check whether our current property equals name. So in JavaScript context, we can say equals, but in TypeScript, we say whether it is a subtype of literal name key. It will be like more, it will be right to say that. So, okay, prop extends name. If prop extends name, we need to forbid it. It means that we need to use never. Like I said previous, if you want to forbid something, just use never. You always win with this pattern. And otherwise, if property is allowed, we just use a current value. As you might have noticed, name is highlighted because value John is not allowed. It should be never. Let's test our type. Okay, we have never here. It is forbidden, but the error message isn't clear. Like type string is not assignable to type never. What does it mean at all? Why it is not assignable to never? For this purpose, we can use error message. For example, we create type which expects some property, and then we just create template literal string. Here we can use it, error message. Okay. So I will remove this. Okay, so now if we like hover the mouse over our name, we will see that type John is not assignable to type property name, is forbidden. So it is more clear now, or for our teammate, that we just are not allowed to use name property. Of course, we can do something like that. And error is gone, but at the same time, in our conditional types, we can check whether the name property extends our error message, and in this case it will be still forbidden. What I mean that if property as is name, and if object property extends error message, we should use never, otherwise our error message. I know this type isn't readable at all, but at least we all know what's going on here, and we can go through each line, and at least now we understand what we are doing. Now property name still forbidden because somebody wants to trick TypeScript. Okay. We can switch to other next topic. Our next topic is mutations. It is a very popular question on a Stack Overflow to ask why type string or some other type is not assignable to type never, especially when we want to mutate some value. Believe me, it's very popular questions, and at least once per week I see this sort of questions. What does it mean? It means that somebody wants mutate known type. For example, we have an we have a tuple, it calls path, and we have a pass type, A and B. And we want to get some result where each value equals to a key. How we can do that? We can just use we can use reduce, like we want to be functional programmers. And usually people doing array reduce, they mutate our accumulator. So here we see this error because our path is A and B. We can get rid of this type. It is still A and B, and we know that our accumulator expects key pass and value pass. And furthermore, we know that in this place pass and this pass are equal. So it is not the case that here pass equals A and here B, because for us it's obvious, but not for TypeScript. For TypeScript, this path is always either A or B. TypeScript, it is only about static typing. What does it mean? It means that if we know that index is 0, it means that we are going through our first element. Our variable path is still A or B. And what TypeScript wants to do here? It has a union of A and B, and TypeScript wants to get the most common type for both A and B. It just means that TypeScript will do intersection A and B. And of course, there is no common type for A and B, and intersection of these both types is never. This is why we have a never. So in this case, it is better to use the structuring like in the same way how we do it in our Redux patterns. Okay, so now you know why mutation are not welcome in TypeScript. I'm not, I don't want to say that, hey, you should never mutate your code because every person has their own style. Okay, let's talk about a bit about safer TypeScript, how to make it safer. So, for example, we have two functions. We have two types, type animal and type dog. You see that type dog is a subtype for animal. And also it has extra property true. And we have two functions, animal fn and dog fn. Please just be aware that I have turned off stripped function types flag. It is unsafe, but I have noticed that a lot of projects on the wild are written without all strict flags. So without this flag, it is allowed to assign dog fn to animal fn. In reality, it might be even safe, but it is impossible to prove that this operation is safe. So in theory, this operation isn't safe. How can we fix our problem? How can we make it more safer? We can toggle this flag, and TypeScript will show us an error. But in reality, you're not. If you have a very big project, you can't just experiment with flags, because it will force you to make some adjustments for 1 week, because in this case you need to fix whole your project. Let's turn it to false back. In this case, we can just add extra generic. In fact, we didn't break anything, but now, due to fact that we have used generic, TypeScript doesn't allow us to assign dog fn to animal fn. I didn't find anything about this behavior in documentation, but we still need to know about such kind of tricks in TypeScript. And the next one example I wanted to show you that types, when you use type keyword and interface keyword are very different. You know, somebody sometimes you can hear, oh, what do you prefer to use, types or interface? And somebody can tell you, oh, I like types and I use them. I like interfaces. But it's not about what we like. It's about what will be safer to us to use. For example, types are indexed by the default, whereas interfaces are not. For example, we have function handle record, and this function expects any object. This object has some keys and values. In this case, we can mutate this object. We can, because we don't know what is it like. We don't know nothing about this object. We can mutate it, assign to, and it is okay. We will not get any error. Also, we can use check. Okay. As you might have noticed, if you use object, this record, it is safe. But if you use interface here, interface animal, we will, sorry, I have some problems. Maybe I have tricked myself. And type. Okay, sorry, I need to work. Let's skip this example. I forgot to change my function. Let's not waste time. Safer TypeScript. Let's switch to another section. It is about creating a range of numbers. What does it mean? It means that a new version of TypeScript allows us to create a union of numbers. For example, if you want to create some function which will expect RGB, and we know that each letter of RGB corresponds to a number from 0 to 255. And current version of TypeScript allows us to create this union. If you hover the mouse on octal, you will see that there is a union from 0 to 55. How we can make it produce this number? We need to create a recursive number which will expect our limit, our maximum number, and empty array. And what are we doing here? We just check whether our length of result equals, not equals, but is a subtype of n. We can return our result. Otherwise, we call compute range recursively and add to our result one more element. It's very straightforward, but syntax might be a bit tricky. So here we are allowed to, here TypeScript allows us to use only numbers from 0 to 255. As you see that we are not allowed to use -1 or 256 or for example, just number. For example, let x equals 10. So this x is number. It is just a number. It is not const. So TypeScript infers it to number, and we can use x. And x isn't allowed to use here because we need to double check whether x is in range. What else? TypeScript doesn't allow us to create like the whole RGB string because TypeScript has his own limits. We can create a union which will include no more than 100,000 of elements. And as you might have noticed that this whole string of octals is 16 millions. So it is too much for TypeScript. Otherwise, it would be not performant to create this union. Okay, so you know that in TypeScript it is possible to validate RGB. What else? Let's stick with RGB for a while. RGB, this technique which we have used previously to validate our arguments allows us to validate decimal part of string, of number. How we can do it? We have created alpha function, and this function expects alpha number for our RGB. What does it do? So as you see, alpha is number, but when I validate it, I have wrapped this alpha into string. Why I have do it? Because it is hard to infer, it is hard to create as a static type a decimal part of number. So we are allowed to create only like 1, 2, 3, but not 1.2 in type system, because we are operating only on array length or on tuple length. So how can we validate it? We can create decimal part like from 0 to 99 here, and then we can wrap this number into string and just add 0. So here we have 0, 0, 0.17, 18, 21, etc. And here we can just check whether our provided alpha extends our alpha channel. It is a set of all allowed alpha numbers. If it is allowed, we leave alpha, otherwise we replace it with never. Because here we have 3 digits after dot, it is not allowed, but if you remove 1, 5, it will be allowed. 1 is allowed. For example, -1 isn't allowed. Okay, so now you know that it is also possible to do some validation for decimal part. Another one very common problem is that array prototype includes doesn't work properly, or at least we think that it doesn't work properly with immutable arrays. For example, it works with array, but it doesn't work with tuple. Please distinguish tuple and arrays, because tuple is immutable list, it is fixed size, and array is mutable list. Okay, due to some because it is by design that TypeScript doesn't allow us to check, to make this helper. But we can overcome this problem. We can carry this function. How we can do it? For example, here we have a list of countries. It is, as you might have noticed, it is a tuple or immutable list. And what we need to do, we need to check whether, for example, some country exists in this list. For example, how we can do it? We can use spread syntaxes in TypeScript just to infer literal provided argument. Okay, so for example, this function, this tuple is carried function. So here we have one function list, and this function returns another one function which expects an element and a primitive element, because includes works for primitive values. At least in a way we expect it works with primitive values. So here you see that argument list is inferred properly. It is Poland, USA, UK, and includes return us another one function which expects generalized type. So this function doesn't expect from us any element from the set, but generalized type. What does it mean? That type test, if we will provide here, for example, literal type hello, it will return us just string. Or for example, 2, it will return us number, not 2, but like more wider type. This technique allows us to use includes, but unfortunately with some runtime overhead. So, you know, in order to make TypeScript happy, we need to make this, we need to carry this function. And sorry, not carry, but make this make a partial application. Okay, but by the way, if we use condition with includes, if it returns true, then TypeScript is able to figure out that our argument str is the part of the array. Okay. About function overloading, it is a very quick section. From time to time, people want to use conditional types in a place where TypeScript expects return type. It doesn't work. This conditional type works here, but not here. How we can overcome it? We can just overload our function. So what does it mean? It means that we need to write this function again with our conditional type, and it works. So please, you will not find, please don't waste your time. You will not find any other solution. Of course, you always can use type assertion as and paste here our conditional type. But some people don't like to use type assertion. I don't like use type assertions, so I prefer to use overloading. It's up to you. Just to make sure that you know that if you want to use conditional types in a place of return time, please like overload your function. About enum issues. You probably already know, if you have worked with TypeScript, that enums or enums are not safe. What does it mean? For example, we have an enum, my enum, it is 1 and 2. So 1 corresponds to 0, 2 corresponds to 1. Sorry, bad naming. And what if our function expects this enum, this numbers enum? It allows us to provide -1, 0, 1, but also it allows us to provide -1, none, infinity, 0.0001, and etc. It is very unsafe behavior, so I encourage you to at least try to avoid this type of enums. And if you want to use enum, please use, for example, regular object const my enum, and provide just provide these values, and then you can declare as const, and then you can use just type my enum. Okay, but we can it is possible in TypeScript. If you, for example, let's imagine that you have 1 million, okay, not 1 million, but 10 enums, 10 numeric enums, and nobody wants to rewrite all our code base. We just want to make it work without, and we don't want to affect our runtime. In order to do that, we can create like utility types. What this type do? This is our validation type, is key valid. This type expects our initial value, our number, because enum is inferred as a number, and our second type is type of our enum, that we want to allow for our function. Then our initial value we are wrapping in a string, and then we use conditional type. We want to check whether this stringified number is a subtype of enum value. Because we are running out of time, you can find this example on my GitHub repo, and you can experiment with this type, and I believe you will figure out how it works. Like my point, I want to show you that this problem is possible, can be fixed, and with help of this validation type, we can check whether our enum is allowed or not. For example, handle enum allow us to use my enum 1, allows us to use 0, allows us to use 1, but it doesn't allow us to use any other number. So in fact, handle enum allows us to use only 0 or 1. Okay, so we know that enums in numerical enums in TypeScript are not safe, but it is possible to overcome this problem. And let's switch to another one section. It is about function intersection. You should know that function intersection, I mean that we have two functions, we can merge them, produces for us an function overloading. So we can say that intersection of functions equals to their overloadings, but it is true only in 90%. It is not always true. There are some tricky cases with generics which doesn't work if you intersect your function. Okay, let's imagine very simple example. We have a function, we have a React component, which I have called component. And I want this component to expect a union of props. So I want to make sure that this component allows me to provide either checked or either checkbox type of properties or drop down. So one or another one, not both. Here, because how union works in TypeScript, TypeScript allows me to provide checked, it is a part of checkbox, and option and selected option is a part of dropdown. So it's some kind of mistake because I want either one of another one. How I can fix it? I can just create an intersection of FC type. Please keep in mind that FC type, it is just a type of a function. FC type is nothing more than an interface. If you see in interface these types of syntaxes, it means that it's just a function. So it is very easy to fix this problem. I can use checkbox and drop down. Now TypeScript knows that my component is an overloaded React functional component. It is either one function or another. It means that I'm allowed to use either options and selected options, either checked. And you see there is no error, but there is an error if I will provide like two unions at the same time. Okay, now we can switch to our last topic. We have maybe 2 minutes. I just wanted you to say that there are very complicated types in TypeScript. They are not always readable. Sometimes it is very hard to explain what's going on there, but I just wanted to show you what we can create in TypeScript in our static type system. Here I have created several utility types. First type is coordinates. It is just a string which contains 2 numbers. This is like, it is allowed part of string. Type last returns last element from our tuple, and concat previous concatenates last element with coordinates from the tuple. And this is the most complicated repeat like on this page type. What does it do? It creates a repetitive pattern with our strings coordinates. How does it work? My location, you see that it allows us to use either one coordinate or 2 coordinates. Here you can see number, number, or number, number, semicolon, number, number. We can make it, for example, allow up to 5 coordinates. Error is gone because we have it's mean up to 5, not we can use less but no more. Here we have 1, 2, 3. It is allowed, and here we have an error because there is no semicolon. We can experiment with it. We can try to provide, for example, 50, and it still works. More information about these examples you can find on my blog. There are several articles with these topics. Maybe you will find more explanation. Maybe I wasn't clear enough. Okay, thank you very much. Also, I want to thank you, my wife, for continuous support. I just want to say to her that I love her very much. Okay, thank you very much. Thank you for attention.
Hello, Serhii. Welcome back. Thank you for the amazing talk. Also, another one with Visual Studio Code. Good day so far. Good day so far, I have to say. So we have a few minutes left, so let's jump into some questions, I would say. Maybe first one, why TypeScript? What do you mean are the advantages? Why do you use it?
I think it's like, maybe for me it's obvious because of type system, because JavaScript doesn't allow you to use types. And so honestly, I just like how TypeScript type system works. Of course, there are many alternatives for front end. If you are talking about static typing, we can use RESTscript, Fable or Fable JS. But because I have, for now, I have a lot of experience with TypeScript, and it is hard to find a project with RESTscript. I work with TypeScript, and TypeScript is continuously growing. TypeScript team every month is adding some new features. So I like this language.
So it's very alive.
Yes, very alive. It's very good for this language. Yes.
Perfect. So also you work as a senior front-end developer. Maybe you want to give some insights on what experience do you need to be a front-end developer? Do you have suggestions for like languages or like best practices on how to become front-end developer?
I think in order, it's seniority. Seniority is it very depends. I might be a senior if you are talking about if you are talking about front-end section. I might be a senior if I work with React library, if I know it very well. I know some, for example, algorithms, complexity, beacon notation, and I can call myself senior. But if I start work with some project with Angular or I don't know, some other library which I don't know, with some CSS frameworks I don't know, it will take some time to switch to this library. So I would say that if you want to be senior front-end developer, it might be a good idea just to stick with one library, learn it, see how it works under the hood, see the source code, and you will make some open source contribution, so other people will check your work, will give you some feedback. Maybe it will help, but it's very like wide question. Everybody has their own opinion how to become senior front-end developer. So it depends, I would say.
And speaking about front-end development as a whole, not only as a like senior developer or something, do you have any further resources like I don't know, YouTubers, blogs, books, something like that you can
Okay, so honestly, I am focused more like on type systems. So I don't, for example, I don't read a lot about, for example, some React blogs, how to become better React developer. I focus more on the type system. For example, I like how Rust type system works. I like code safety. So I'm more focused on these topics rather than like learning, for example, new CSS frameworks or things like that. But it doesn't mean that you, of course, that you shouldn't learn it. You definitely should. And for example, last time I was forced to learn Tailwind CSS library. It works well and it's scalable. So.
Okay, and how did you ended up in the field? What were your pushing buttons to end up in front-end development?
So when I started my developer career, I started from PHP. I thought that I wanted to be a backend developer, but then I realized that you do backend, but it's hard to see your results of your work. So you have some abstraction in your head, of course, but it's hard to show somebody, hey, look what I have done, for example. And when I started to learn CSS and JavaScript, I realized that it is, for me, it is more interesting. So this is why I started front-end path rather than backend.
Yeah, that sounds relatable. All right, Serhii, thank you so much for the amazing talk. I hope you and your loved ones all stay safe. All the best, and hope to see you next time. Bye.
Thank you very much. Bye.
So, and after these first two amazing speakers, we'll have a short break of about 10 minutes. Until then, stay tuned.
found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
So, hello and welcome back, everyone. I hope you had time to grab a coffee and are now prepared for the last speaker of today. He is software architect and developer advocate at I/O, and with his 15 years of experience, he's a real expert in the field. Last, but certainly not least, welcome with me, Lucien.
Hello.
Hello, Lucien. How are you doing?
I'm fine, thank you. How are you?
I'm fine, thank you. So, Lucien, what are we going to hear from you today?
Well, today I'm going to talk to you about something that is really close to my heart. As an audiophile as well. I actually write my own music player in my spare time, but I'm a web developer, so I'm only using web technology. But I have rewritten that music player, I think 4 or 5 times now, using different frameworks. And at one point, I was like, yeah, I'm kind of done with rewriting my same UI over and over again. Is there something that I can use that is really interchangeable between the different frameworks that we have, right? So, for example, because the first version of my music player was written using Knockout JS. Well, nobody is using Knockout JS anymore, especially not me. So what I did was I rewrote it using Angular JS. Well, that's end of life, so I needed to think of something else. Well, then I switched to Angular, and just Angular. Version 2 to version 10, I think. And then I've stopped using Angular altogether. And at my company, we started to use Vue and React more and more, which is, of course, a few years ago already. So I had to rewrite. So I rewrote it again. And there are some things that for me personally, I would say it's better just to use the platform, to use what the browser gives you. And there is a new technology. Well, it's already around for a few years, but it's getting more and more traction nowadays. And a technology where we can write complex logic while giving that and sharing that quite easily with other developers.
Okay,
that's called a web component.
Sounds very interesting.
Yeah, I think it is.
I would say, without further ado, start your presentation, and the stage is yours.
Thank you. So, thank you all for joining. Like I've said in the introduction, I'm going to talk about a few things that are close to my heart as a software developer, but also as a music lover. During the day, I work at I/O as a software architect, and at night, I work at my company doesn't have a name because I am not a company. So I work at Lucien Immink, and I write a music player completely written in web technology. So HTML, CSS, and JavaScript. And if you're writing a music player, one of the most important things, or one of the most visible things that you have, is album art. So I'm going to talk to you about album art. And I started out the quest of album art with a simple question. I'm a software architect, so I'm used to defining and reading use cases. And my use case was I want to display album art. Maybe I have an artist name, or maybe I have an artist and an album name. So if I give it to you, I want you to show me the art. So for example, if I give you the name of my favorite artist, Arian, I want to show a picture of that guy, that tall guy from the Netherlands. But if I also give an album name, I want to display the art for that specific album. So let's say Omega by the Dutch metal symphony band Epica. It's a simple question, but it requires quite some work actually to get this right. And especially if you want to make something that other people can use as well. Because if I can fetch album art, maybe I can share it with the community so that the community doesn't have to rethink all the steps that I needed to do. But I wanted to give them to them in a manner that it's easy to understand. So it is a simple statement, fetch my art, but we do need some work. Like, where the hell can we find that album art? There are different providers that we can query to get that album art. Maybe one provider is slower at the time than another. I just want the fastest and the most efficient way to get my art. But I also want to make sure that once I have the art, that I don't have to refetch the art over and over again. So I want to cache it on my local system. And of course, I'm not entirely sure on what kind of a device my end user is using my music player. So I need to optimize that image for the required dimensions. Maybe it's just a little thumbnail, or maybe it's full screen. And I have to do a lot of other things. I can think of so many other things that I want to do, but the most important here is that I want to do it without bothering the other developers. So I want to do the heavy lifting, and I want to give you something that if you need album art, you just type in, I want album art for U2. You press enter, and it magically shows you the album art. So so what I can give you without viewing from a pure web developer perspective is some kind of logic that I write, and I can present it to you as a script. So for example, I give you a function and you provide me the artist and the album, and I'll do some magic. And once I'm done, I will return the magic for you. And of course, it's all synchronic. Well, maybe not, but that's all stuff that I need to think about. That's not what you need to think about if you are implementing my album art JS. Because of course, my API will describe that you just include my album art JS file, that you need to provide a placeholder where we can update the contents of that art, and then you just type in the parameters that you want, like I want the awesome album on a column by tool. And once I have that album art, I want to put that in my placeholder or in my div with the ID art. But I've said that in the previous slide that I'm returning an image tag. So you need to update the inner HTML of that art placeholder, which you shouldn't do, because you shouldn't ever trust external HTML, because next time I will put in the image and a keylogger without you knowing it. So of course, everyone knows that I can be trusted because I have a very trustful face, right? But no, you can't ever be sure, so never trust external HTML. And even though we can make this work, it works until it becomes too complex, because there will always be multiple new questions that arrive that we have to answer ourselves as well. And if I add a new feature, I need to tell it to you. Hey, I've got a new feature. Okay, cool. I'll implement the new feature, and maybe I've changed the API of the feature. You need to update that as well. If you're on the same team, I can walk over and go to your desk and tell you what has changed. If you're in a different country, I need to update my documentation. And in the end, it requires a lot of shared knowledge between the both of us, what you're trying to do and what I'm trying to do. That order requires a lot of copy pasting, because I can give you an example, but in that example, as I've shown, you need to include my script. You need to update your own page. You need to call my script, and then with that result, update your own files. That if I'm not telling it to you, you can use my examples to get it working for you. But if instead of album art, we're talking about something more UI related, one other major important question that arises is, who is responsible for the styling of this page? Because it's not my page, but I am providing you UI elements. So who is responsible for what exactly? When I started out my career about 15 years ago, everything was built in Flash and iframes. But it's not always a solution, of course. Nowadays, with responsive designs, with multiple devices where our code should work, we just cannot always rely on these older technologies. So we need newer technologies, like a framework. So let's make it in our favorite framework of choice as a component. In the introduction, I've said that I've been working on this music player for a few years now, and I've rewritten that music player over and over again. I've written it in Knockout. I've written it in AngularJS, in Angular, just Angular. I've written it in Vue, React, Svelte, over and over and over again. And in every single incarnation of that music player, I needed some simple components that I wanted to reuse without rewriting them. But yeah, I have done this. So in the case of an album art component, I have rewritten my album art component in Vue, for example. But it's the 18th of May, and on the 18th of May, we're all using React. Sorry. So that means that I have to rewrite my enormous component. Of course, album art isn't that enormous, but let's say that we have an enormous component. So I have to rewrite that enormous component using that other framework because it's Wednesday, so we're using Svelte. Wait a minute, Svelte or React? We're using both nowadays. Oh, okay. So have fun rewriting that. And of course, please write it in TypeScript because I need to know your types. And I'm off for a beer or two. This, of course, is a quote by your least favorite coworker or boss type of person or someone else that you just hate for saying this. Hopefully, I am not that person. But I can tell you who I am. My name is Lucien Immink. I'm a bachelor in engineering. And like I've said, I'm hopefully not that least favorite person that I was referring to. This is my face, just to be sure that it's still the same person that is giving this presentation. I've totally not ripped it from someone else and just put in my own face here. No, actually, no. I can give you the source code. You'll see. I'm a software architect and developer advocate at I/O, and we're a company in the Netherlands, Belgium, Sweden, and Hungary. And we're hungry to extend to more countries in Europe as well. I/O does not stand for infinite opportunities, but we do see them anywhere and everywhere. I/O has different campi. Is campi the plural of campus? Oh, okay. Campus. I actually work at campus Eindhoven in this beautiful building. And this is a picture of our building from a few years ago. I can see that because the name of the building is still called Isaac, while we are now part of I/O. And although there is a label here that says there is a greenery called the Friso Geerlings plantsoen, there's nothing on this picture, but trust me, there is green in front of our door nowadays. By the way, Friso Geerlings is my CTO, and he just called the local council one day and said, hey, can we please do something about all that concrete in front of our office? Local council said, yeah, okay, we'll think of something cool, and they came up with this, and it's awesome. The man has his own plantsoen in Eindhoven. Wow. Then there's nothing more for him to do, right? Okay, enough about me, enough about I/O, enough about the introduction. Let's dive in. Let's talk about the thing that helped me out in my quest for sharing album art. Because I'm going to talk about a thing called web components. And to understand web components, we need to figure out what a web component exactly is. And the thing is, a web component is not just one thing. It are multiple things combined together to get sharing between different frameworks easy, right? And the first thing that we need to understand is a concept called templates. If you're building a UI, you're quite used to using a template, right? So for example, we have a table with multiple rows. We just define one row and copy paste that row as much as we need. Maybe we put it in an iterator. But actually what you're doing there is you're using a template. Maybe it's not called a template, but it's the same principle at least. What web components have added to the HTML standard is the template element. So now you can use a template element in your HTML pages. And it's used for holding HTML. So let's take a look at an example. I've got a template here with the ID template because, well, I'm not really good at names. And inside the template, I can add normal HTML. So I've added a card, maybe using Bootstrap or something. Yeah, I'm that old. I'm not never mind. Adding a card, and inside that card, I've added an image with my artist album art, and while it's loading, I'm showing some sort of a placeholder, and I can also add some extra information like the artist name and its bio. But there is something very peculiar about a template, because if you add this to your page, you won't see anything, because this DOM is not live. The document object model inside a template is not live. Although you have added it to your own light DOM, it will not render. It won't do any calls to fetch that image that I was referring to. If I have CSS that is applied to my card classes, nothing is applied because it's not live. And if I've added, for example, a script tag to that template, that script will not be executed. So what can we do with it? Well, that's a good question. What we can do is we can use JavaScript to sort of clone the template. So when the browser vendors have added the template tag to the HTML, from that point on, what you can do is, first of all, you can test if you can use a template and maybe provide a fallback for if you can't use a template. So this is the start of a polyfill maybe. But if you can use a template, you can query using vanilla JavaScript, query your template element and clone the contents of that template. You'll see on line 5 that I'm using document.import node, which is used to import the template contents into JavaScript with the variable true attached, meaning that I can that I copy the contents and not move the contents. So you can either choose to clone it once, or one-off, then you'll have to provide the false attribute, or you can set it to true, so you can reclone it over and over again. Once you have that clone, you can just use it as any normal HTML element as you would in JavaScript. So in this case, I can query my image and set the attribute of the source. I can set the source attribute to the URL that I'm fetching from somewhere else, maybe one of the providers that provides my album art. And once I'm done populating the values in my clone, I can add it to my document. So in this example, I just add it to the bottom of the page. But once I do, the image is fetched. Once I do, CSS is applied to the node. And once I do, script is executed, because once I do that, that piece of document object comes alive. Right? So with templates, we have a mechanism to populate the contents of an HTML node without showing it anywhere. So it's all in memory, and attaching it to the document object model. That's very nice, and it's a very good feature to have. But it's not all, because if that's all, then I still need to send over my template, and you still need to copy paste that whole template, which is still an enormous list of HTML elements. What I do want to send you is a single element, which is called a custom element. And a custom element gives us the ability to create custom elements that encapsulate your functionality on an HTML page, rather than having to do with a long nested batch of elements that together provide a custom page feature. So instead of sending that template that I've just shown you, I can just send you album art, period. In order to make a custom element, what we need to do is we need to extend the default HTML element. And sorry for the functional programmers out there, this is all class-based programming. So what we do here is we create a new class, in this case called album art, that extends the HTML element. Because it's based on class-based programming, we have a constructor to create an instance of this class. And if we have a constructor, we always need to call the super of that constructor first, because that's how things work. But once that's done, I can have my own magic. I can do whatever I want with this element. So then I have my custom element living in JavaScript, but how can I attach it to the document object model? Well, what I need to do there is I need to define the name of that custom element that is used in the document object model, and I need to assign it to my class. So what you can do by using the custom element.define method is you can give a name to your class, and that name that you will see, in my case, album-art, needs to have a dash, because all elements without a dash are reserved for future use in the HTML standard. That also means that the HTML standard itself will never use a dashed element name. So everything with a dash means this is a custom element. So if you ever open an HTML source and you see something with a dash, you know they're using web components. I've called it album art. You can call it my album art. You can call it name of my company album art. Whatever. It's up to you. It's custom. Without this single line of JavaScript, if I just put in my custom element in an HTML document, the renderer will not recognize this as a custom element and will just treat it as whatever it has as a fallback. And the fallback for an unknown element is a div. So we will just treat it as a div. If you have specific properties, it will just ignore them. If you have properties that are part of the HTML standard, it will apply them. So if you put a style attribute in your custom element, it will still apply that, but it will treat your element as a div. Nothing more, nothing less. You can also customize built-in elements. So instead of extending the HTML element, you can also extend a built-in element. So for example, the ordered list, where we still need to call our constructor, where we still need to call our super, where we can still do our magic. And at the end, the only thing that actually changes, except for the implementation, of course, is that instead of defining the class directly to the name, what we do is we assign the class to the name with the extra options that it extends a current default element, in this case, the ordered list. And to use it, instead of using sortable list, you need to point to the ordered list itself and tell it is a whatever you have made of it. So in this case, it is a sortable list. But this also means that if you extend an element, but somebody for some reason doesn't have your custom element implementation, it will still show the ordered list. So you automatically have a fallback. And once you have registered them, once you have created the contents of a custom element, you can use them anywhere. So for example, I can just insert somewhere in an article that I have art for 2-pack. And in my album art custom element, I've also defined what we call a slot, where you can point to a specific part of the DOM of the album art web component, where the outer DOM can inject content. So in this case, I tell the album art component that it should search for the slot called bio and put in this text, this lorem ipsum in gangsta style. If it can't find that slot, it will just render it. It will, I think, it don't even render it at all. That's a good question for the Q&A. Not that I know the answer by then, but still, sorry. Lorem ipsum. Right, so we have templates, we have custom elements, and custom elements, they need lifecycle callbacks. Because of, what do I mean with lifecycle callbacks? Well, if you, for example, add a component to the HTML DOM, you get a connected callback, meaning that you can act when a component is added to your DOM. You can also do something when it's removed from your DOM. You can also do something when you move it from one DOM to another DOM on the same page. So for example, if you're using frames. But one of the most important, actually, I think, is the attribute changed callback. If you open DevTools, you can, for example, you can easily change all the attributes that you have on your custom elements. So, for example, the artist, instead of Tupac, I want another rapper. I can just change that live in my DevTools. And if I have an attribute changed callback implementation in my custom element class, I can actually act on the change as well. And we're still not there, actually. We have templates, we have custom elements. But what about the styling, right? Like I've said, who is responsible for the styling? Well, that's where Shadow DOM comes in handy. And with the Shadow DOM, we also have the opposite. That's the Light DOM. That's your own document. And with the Shadow DOM, what you can do is you can actually sort of hide the part of the DOM from the Light DOM. So what it does, it allows a hidden DOM tree to be attached to elements in the regular DOM tree. So maybe a picture can help. So what I can do, for example, is I have a normal document tree with my web component, which is then called a shadow host. And inside that shadow host, I can build my own standalone document object model, right? With an image, with a paragraph, with anything. But if we inspect it, we'll only see, yeah, it has a shadow DOM. That's all. We cannot query the elements directly, or well, maybe we can. I'll show you in a minute. To use a shadow DOM, that's actually quite easy within an element. So you've extended the HTML element, and what you then can do after you have called the constructor and the super is that you can attach a shadow DOM to this element by calling the attach shadow. You can set a mode. It's either open or closed. Open means that the Light DOM can access all the elements from the shadow DOM by using JavaScript. If you set it to closed, you'll try. You're saying, well, please don't touch my elements. So that those are mine. Don't go near them. The only thing is, even though you're giving your shadow the mode closed, you can still access them from the outside element. And that's because you need to use this shadow constants that you've created to extend your shadow DOM with all your shadow DOM elements. But it also means that you can access that constants and perhaps change some of the contents. So let's dive into a simple example. I've added my shadow DOM as closed, and I've assigned it to the _root variable of my custom element. But that means, and what I can do is I can query my web component, ask if I have a shadow root. It will say no because it's closed, and I'm not going to tell you that I've got a shadow root. Go away. But if I know, for example, the name of that property that's bound to my custom element, I can still get the contents. Maybe you can query the element and get the correct name, because it's not always _root, of course. So in this brief example, what I've done is I've just built a component called my web component with a closed shadow root. I've assigned it to my _root variable, and then I just query the paragraph that's inside and update the contents, and it's still possible. So perhaps it's not even a good idea to close your shadow DOM, because if people want to, they can still access it. What is a good idea is to create your shadow DOM. And to create a shadow DOM, that's actually the same as a normal DOM. So it's just creating elements, adding attributes, maybe checking a placeholder image, maybe checking if your component has an attribute called image. And if it has an image, we can override that placeholder directly, set the placeholder or the overridden image as the source of the image, add the image to my wrapper div, and add my wrapper div to my shadow. So it's just normal DOM manipulation. If you're used to native JavaScript or vanilla JavaScript, this is more of the same. But the best thing about a shadow DOM is that you can apply styling directly and only to the DOM. So I've created the shadow DOM, and if I add this style element to it, although I'm talking about very generic CSS rules like the class wrapper or all image elements, it will only apply styles to the images that are inside the shadow DOM. It cannot leak outside, right? So who is responsible for setting my album art in the correct size and the correct fit and the correct aspect ratio and whatever? That's me. That's me as the owner of the album art web component. If you want to set a color, you can do that as well, but we'll come to that. And we come to that right now. Not a part of the web components standard, but it is so freakingly awesome. And they work so well together as CSS variables. You can define a set of variables that people can override from the light DOM in your web component. So you set the default values like primary or the fallback color or the background color. And if it's not provided by the light DOM, it will apply, for example, in the background color, the variable background to that property background color. But if in a light DOM, someone has said, no, the CSS variable background is blue, it will apply the blue color. So you can provide the fallbacks while the owner of the light DOM, so the owner of the document that includes your web component, is responsible for everything that you have said that can be overridden. So we fixed that issue with CSS variables as well. So what happens if we combine the two together, right? So CSS variables and a shadow DOM, how do they work together? Well, if I'm not using a shadow DOM, and of course I can create a web component without a shadow DOM, I'm just using the global styling. So if anyone in the light DOM has said, well, every image has a border of 10 pixels, then my images in my web components will also have that 10 pixel border. But if I'm using a shadow DOM, I'm using the scope styling. So I can target my own images and only my images. If we combine them together, we can use the CSS variables, making it the best of both worlds, because we can use both the CSS variables so that the light DOM can update whatever we want them to be able to update, while we're also in charge of targeting the CSS styles that we want, that we can change. So that's it. Those are web components, but my presentation isn't done yet. So probably I thought of something else to talk about, because yes, only web components is just web components, right? But the thing is, we want to use them. We want to integrate them. We want to, for example, have a team that works on an application, right? That is implementing our new awesome web component date picker. And the team was the same team that last year said, well, I'm not going to use your date picker because it's written in Vue and we're using Angular. We've rewritten our date picker to a web component, and now they can. But they need to tell their compiler a few things. So if you're using Angular, for example, you need to tell your compiler that we're using the custom elements schema, meaning every element that it finds that has a dash is excluded from the Angular compiler, right? Because otherwise it is treated as an Angular component. As an Angular component. And you can't use the web component in Angular directly because it isn't an Angular component. So you need to exclude it from the compiler, and it will just skip the tag altogether, treat it as is, but it will still bind the properties and the values to it, of course. So what you can do afterwards, after you've said to your compiler, please don't do it, please don't do anything with it, I can import my web component and then use it, right? So I can bind my Angular variables to my component, and my Angular application can listen to the events that my web component will emit, for example. If we're using React, it's even easier. You just use it. Well, with a small remark, and that is that yes, although it can easily render a web component, it cannot easily parse the props that I'm using in this case, nor the event listeners that I've put on my own web component. There is a lot of work going on in getting the interoperability between React and web components up to the standard that we are used to. If we're looking at Angular or Vue, for example, we're getting there, but it's still not entirely as smooth as you'd expect, unfortunately. What is smooth, though, is Vue. You tell your compiler, please ignore this element. In this case, it is a regular expression, so everything that starts with album-art is ignored, or everything that is album art is ignored. And once I've ignored it, I can import it in my scripts and use it in my. Wait a minute. Vue is using templates. Yes, they are using the HTML templates. It's nice for a coffee break chat. Did you know that Vue uses the HTML template tag that is used for web components? No, well, now you do. We can bind our properties. We can listen to events without any problem, as long as we tell the compiler that it's not a Vue element. What we can also do in both Angular, React, and Vue is not import our component during build time, but during runtime. So instead of setting it here, like I've done for the Vue component, in the Vue component itself, you can also just include the script during runtime, making your bundle size a little bit smaller, and making the downside is, of course, that the web component first needs to be downloaded before it can be used, while the rest of the application is already downloaded. So you can have a flash undownload content. Some people don't enjoy working with vanilla JavaScript, and I can understand that because you need to do quite a lot of things yourself. There are already a few libraries out there that will help you to create and to implement web components way faster. The two most used at the moment are Lit and Stencil. Skate is also a very good option, and then there are already many more. But at the moment, it's the most used are Lit and Stencil. So those are the first that I would take a look at if I'm starting with web components that are more difficult to make than displaying album art. And talking about web components that are a little bit more difficult to make, but also web components that I actually already use during my daily work. For example, a friend of mine has written a web component called render plant UML. So as a software architect, I'm used to writing UML diagrams. Actor has an action to actor 2 that says, hooray, we have a working example. The cool thing with this web component is that I can update the contents of my UML during build time, while the rendering of this image is done during runtime. Normally, what I had to do was do the same as what I'm doing here, telling my plant UML server, please render this image for me during build time. Now I can update my documentation site without updating my separate images afterwards, or somewhere down the line, and probably forgetting them, of course, giving me a site with outdated documentation or incorrect documentation, which is even worse. With this web component, I don't have to think about it anymore. I was just referring to Stencil as one of the libraries that you can use to build web components. Well, Stencil is perfect for writing UI components, perfect for writing UI design systems. But you get a lot of components. If you're used to design systems, you'll know you will always get a lot of components. What is the API of all those components? How can I know what properties do I have on my custom elements? Well, there's a web component for describing web components. So in this case, this is a web component that uses the custom elements JSON that you'll get when you render a web component using stencil, and it will parse that JSON and will put it in the UI that you see in front of you. So you can easily check your properties, attributes, slots, and events that are on the element. And this is always kept up to date because you're using the same version of your custom elements JSON as you are using to build them, because the custom elements JSON is generated from the source code itself. Again, my documentation stays up to date and is always correct. But you can use web components for so many other things, like maybe something like a grid, or showing a model, or getting a wizard into a page without writing everything, using an enormous library just for something like 3 elements that need to slide. You can think of takeovers, or maybe one of the best UI elements ever, the endless list, where you already see how long the list is without rendering all the elements. And of course, most important, you can use it to write or to show album art. And that's exactly what I've done. So in this example, this example is the example that I've shown at the start. And since the presentation that I'm giving is all done in JavaScript, or in JavaScript in web, so it is just a website, what I've also done is make sure that you can, for example, update your own preferred artist and render that artist instead, because that's what the album art web component is all about. So sorry, Arjen, you need to go away. I've changed my mind. My new favorite artist is called Muse, and I will try to fetch the art from Muse, but unfortunately it's not found. So I've got my fallback image. So yeah, you're absolutely correct. My new favorite artist is called U2. And boy, do we have art for U2. What you see in below is the style of the light DOM, meaning this is the DOM that is shown above. So I have a grid, display grid, with a gap. I have album art, display block, with a width of 100%. I can change, of course, I can change this CSS, but yeah, why should I? You could, but that the album art will always be displayed as big and as pretty as possible, which is part of the album art web components CSS that you can't change. And so we come to an end. After 44 minutes, I've shown you that we have web components like the album art web component. Web components that are an API to create new custom reusable HTML tags with controlled style and markup that cannot leak to the outside. I've shown you that custom elements built on the web component standard will work across all modern browsers. Well, I haven't shown you that, but trust me, it does. And that they can be used with any JavaScript library or framework as long as that framework works with HTML, which is why React is sort of troublesome at the moment. I've shown you that web components consist of HTML templates, custom elements, and the shadow DOM. Those 3 powers combined are what we call a web component. I've shown you that a web component loves CSS variables, that it integrates well with the modern frameworks, and of course, that's the only reason why I'm here, to show you that it can fetch some album art. And with that, I hope you have a very nice day and I hope to see you soon. Thank you.
Hi, Lucien. Hello, welcome back.
Thank
you so much for this awesome talk. And I hope, as we have some minutes left, you're ready for a short Q&A?
Yeah, sure.
As we got a few questions. First question from Pete. When would you use a web component and why?
Well, I'm quite fond of using web components nowadays for DOM UI components. So I think I was referring to a design system. So when we're building larger applications, you'll see that you need buttons and you need drop downs and you need a menu, that kind of things. If I know that either my application will live long, right? So it's not a one-off, but it's a thing that will live longer than one iteration of our code. Or if I know that I'm working with multiple teams that are not using this, or perhaps are not using the same framework, I would opt for a web component without thinking about it. And of course, if you build something, a utility component like I've done with the album art component that you just want to share with the community, then a web component would be my first choice as well.
All right, thanks. Another question from the Curious Dev cookie. What do you know about and think of the declarative implementation of web components or custom elements?
Wow. That's a good question, but I'm not entirely sure if I can answer it. I've no idea. The declarative version. No, sorry.
All right. Nobody's perfect.
Learning something new each day.
Yes. All right, then maybe a follow-up question from Pete, and also, when wouldn't you consider web components? Like,
yeah.
You explained why, and now why not?
When not. Well, then I would actually say it's indeed the other way around. So if I know that I'm working with one team that is really good with, for example, React, and only that team will use our components, then why should we introduce a new technology stack? And also for if I create, for example, a one-off website where I know that it's live for a specific event, for example, and afterwards we're not doing anything more with it. Again, why introduce a new technology stack in that case?
All right, thanks. I hope that made it clear. Also a question from Sarah. How about accessibility?
Oh, that's a good question, but it's also a very mean question. Accessibility without a shadow DOM is super easy because it's all part of the same document object model. So there is no issue. But if you're using a shadow DOM, then you will run into some issues because, like I've explained, the shadow DOM isn't normally accessible from the outside DOM, so from the light DOM, so to speak. There is a W3 working group working on getting something that is closely related to both, and it's actually something like an accessibility object model describing the complete object model for accessibility use for an application, including everything that's in the shadow DOM. So you can declare what your shadow DOM is using, and those will be exposed to that accessibility DOM so that your accessibility tools can use that.
All right, thank you for that answer as well. And one more question from Harry. Can you create a web component that replaces user input fields like a date field, for example?
I wish, but no. You cannot replace. Well, you can extend, like I've said, the built-in elements with one exception, and that's the elements where user interaction is required. So, for example, an input field, type date, for example. Unfortunately, you cannot override that. So my big dream is still to build the one and only date picker ever that everyone is using everywhere, anytime. But unfortunately, you still have to hook it up to your own library or framework because you cannot override it from within the browser, unfortunately. And it has good reasons, of course, to be able to do that.
All right, Lucien, thank you for clarifying that as well. Oh, and Curious Dev Cookie wants to thank you anyway.
It was all my pleasure to share this information with you guys.
Lucien, thank you so much for this very interesting and informative talk. It was a pleasure having you, and I hope to see you at another live day. Bye.
All right. Thank you. Have a nice day. Bye-bye.
So, and now that we are done with the speakers, all there's left to say from me is, this was sadly the last topic day before our World Congress. We will continue in September, so stay tuned for that. You get information for that at WeAreDevelopers.com in the live section. And now that we are over with the talk, is also the time that you can go to worldcongress.dev to save your tickets for our World Congress starting on June the 14th in Berlin. Hope to see a lot of you there. And until then, bye.
Good morning,
Everything is being influenced by code written by developers.
At some point, you're going to wake up and say, what the hell am I doing?
It's hard to believe. It's the largest group I've ever been in front of, I think.
We develop the future.